Welcome to qnawire.
Okay, so problem 752. Essentially, we have a baseball that is moving. We have a baseball that starts from the ground and has a certain velocity, and we're given a point later with a horizontal velocity, and then it comes down to the ground with a certain velocity as well. And we're told the positions and the velocities in the table. I didn't copy that table, but you can find that in the text. And so what we're asked to do is find the how much work the air does on the baseball in parts A and parts B. So this is part A, and this is part B. How much work is done on this baseball in each of those parts? And the part C is just explained. So in order to do that, I'm going to find what the energy at each of these points is. So that's at t equals 0, t equals 3.05, and t equals 6.59. And I'll label those points as 1 and 2 and 3. So if I can write 1 there. Okay, so we have E1. There's only kinetic energy there because we're defining this potential due to gravity here to be UG equals 0. So E1 is just going to be made up of kinetic energy. So we have 1/2 times the mass of the baseball. And then if we find the velocity vector due to components of the Vx and Vy, so we have Vx squared plus Vy squared. As these vectors are perpendicular to each other, Pythagorean rule applies, so then you would just get V squared, and then we can find that that's 1/2 mass 50 squared. If you remember your special triangles, we have 30, 40. That makes a vector that is 50 long, 3, 4, 5. That's special. Okay, so then that will come down once we plug in mass. That will come out to 181.25 joules. Okay, so 181.25 joules at t equals 0. Okay, then energy at 0.2 at the peak. We have potential energy this time, so mass times gravity, and we're told what the y position is to be 53.6 meters. And we have kinetic energy because it's still moving in the horizontal direction. So that's plus 1/2 mass times velocity squared, so 18.6 squared. Okay, so then all that comes out to, what does that come out to? That comes out to 76.24 plus the 25.08, and that comes out to 101.32 joules. Okay, so immediately here, we see that the energy from point 1 to energy at point 2, it goes down. And because the only work that can be done on that baseball is done by the air at that time. So that means that work done by air is, since it decreases the amount of total energy, it's negative. So it's just going to be the difference between them. So we have work due to air from 1 to 2. So 1 to 2 is going to be E2 minus E1, and that's just going to be negative 79.93 joules. So that's part A. Part B then is going to be a difference between energy 3 and energy 2. So again, now that we're at the base here now, we have potential energy equals 0. So that means we just have kinetic energy. So then we can just write down we have 1/2 mass Again, these are perpendicular vectors, so we just add the straightforwardly add those two components velocity squared. So we have 11.9 squared plus a value that is negative 28.7 d. That's the vertical velocity. It is negative because it's going down squared. And then that will get us 69.98 meters joules. And so now the difference between those two, so part B, so work done by air from 2 to 3 is equal to E3 minus E2. That means that we're going to get a negative 31.33 joules. Okay, so then C, we're asked, explain why the magnitude of the answer in part B is smaller than the magnitude of the answer in part A. So that is a discussion on how friction due to a ball traveling through the air works. So if you can imagine, if you push your hand through the air faster, say if you stick your hand out of a car window, you'll feel a greater force acting on your hand as the air pushes your hand, and that is because the friction due to air is going to depend on how fast you're moving. So whether that's linear or that's squared or whatever, we're not entirely sure in this case. It is due to a combination of those components in reality. However, here we see that in the beginning, the velocity is higher than at the second, and then during the second leg of the trip. So then that means that there's going to be greater friction acting on it throughout part A compared to part B. So due to reasons, we have that friction is higher when the velocity is higher.